by intellectual property. Today's topic is what constitutes non-naturally occurring subject matter. This is the first in a three-part series of webinars focused on the impact of the new PTO Section 101 guidelines on patent prosecution across a number of subject areas. All lines have been placed in a listen-only mode. If you have a question during today's presentation, please submit it via the Q&A chat box located in the control panel on the right side of your webinar screen. If we do not have a chance to answer your question prior to the end of today's discussion, we'll follow up directly to make sure you receive an answer. As I've already noted in the chat box, if you'd like to receive a PDF copy of today's presentation or a link to a recording, please send an email request to Aaron West. Today's presenters are John Covert and Miklos Gaszner. At this point, it's my pleasure to turn the call over to John Covert.
Thank you, Erin. And Miklos and I want to welcome kind of friends and clients of Sterne Kessler to our first webinar that examines these examination guidelines. We really kind of refer you to the Patent Office website. They have a great website that has the guidelines, it has the examples. There's more examples to come in the area that pertains to methods. There's instructions for submitting comments, and again, this is the first part. We're basically tackling the issue of what folks originally called kind of products of nature. Next Friday, our colleagues in the electronics practice group are going to be talking about the effects on software patents of these guidelines. And then next week on Thursday, we're going to tackle the issue of diagnostics, and kind of more particularly looking at the methods as well as maybe the sequences and tools that would be provided when you're practicing diagnostic methods. And so today what we want to do is take you through the guidelines, take you through the flow chart and what the PTO calls a two-part test or two-part analysis, get the terms of art out there for you. And again, this is going to be basically kind of confined to products of nature and method claims that are using those products of nature. And so terms of art, first term of art appears at the top of this slide, nature-based products. Nature-based products is the starting point for the analysis. It's a term that's used in the guidance, and we'll be using it a lot today. And it's any product that needs to be examined or placed through this test to identify whether the product of nature exceptions to patentability apply. So what begs the question, what is a nature-based product? If there's something that occurs in nature or looks like it's very closely related, either structurally or functionally, to something that you're going to find in nature. There is not a solid definition. And again, it's a starting point, and so it's going to include the universe of things that could be patent eligible or patent ineligible. It will include both naturally occurring products, or when you walk through these examples, you'll see that some synthetic derivatives of products do kind of fall into the starting material, nature-based products. The conclusion, when you get to the conclusion, you end up with the term product of nature. So product of nature is basically a legal conclusion that you don't have patentable subject matter, or you're really going to have to use that product of nature and have a lot of other claim limitations in your claim to make sure that you have a 101 eligible invention. Other terms of art are going to be markedly different characteristics. We will be spending a lot of time on markedly different characteristics, and then the last term is significantly more than the judicial exception. Just to go back to nature-based products, you'll see at the bottom of this slide some of the nature-based products that are discussed in the examples, and we will go through these in pretty decent detail. And so the new guidance maintains a two-part analysis for the judicial exception to patentability. And what we say when we say maintain, we're referring to the older guidelines that were issued in March of 2014. These latest guidelines were issued in December of 2014. And just right up front, with respect to natural products and nature-based products, these new way of going through this two-part analysis is much more applicant or patentee friendly than the original guidelines. And so probably one of the take-home messages for today is, at least with respect to nature-based products, there is a significant amount of room to operate and obtain patents, significantly much more than you had in the earlier guidelines. And so flowchart on the left, the top box, or decision box, is basically the old 101 guideline. Do you meet one of the statutory classes of invention that's listed in Section 101? And that's just needs to be done. What we're talking about today and in the subsequent webinars are the following two boxes, which are labeled Step 2A, Step 2B. And so we'll start off with Step 2A, and the key here is, does the nature-based product limitation exhibit markedly different characteristics from its naturally occurring counterpart? If the answer is yes, the claim is deemed patent eligible under 101. It's the end of the analysis. If the answer is no, you step down into Step 2B, and you start taking a look to see if the claim as a whole defines subject matter that is significantly more than the judicial exception. And so Step 2B, in determining whether something's significantly more than the judicial exception, this is where we start getting into Alice and Mayo. It's almost the idea of preemption, that your claim has enough other limitations in it that you're not taking away from the public something that was already kind of in nature or part of the commons or public domain. And there, if the answer is yes under 2B, you meet patent eligibility under 101. If no, ultimately that's where you fall out and you're going to get the 101 rejection. And so with significant differences, again, significant differences compared to the earlier guidance in March of 2014. And so we will kind of walk through this. I will handle kind of the first two significant differences from the earlier guidance, and then Miklos will sort of handle kind of the second two differences that really kind of do make this fairly applicant-friendly. Not a perfect world for patent applicants, but much better than what we were looking at with the earlier guidance. And so first aspect here is method of use claims that will recite but do not focus on the nature-based product limitation. And so what are we talking about here? The Patent Office examples kind of cast this in terms of method of using claims. And so you'll see the first italicized claim here, method of treating breast or colon cancer comprising administering an effective amount of amazonic acid to a patient suffering from breast or colon cancer. The amazonic acid in the examples is something that's derived from the Amazon tree. It's a natural product. The specification doesn't indicate that the amazonic acid, when it's taken out of the tree or the leaf, differs in any way from the naturally occurring product. With respect to a process claim like this, the PTO guidelines instruct the examiners to go ahead and examine that claim to find that it meets Section 101 and it's not a judicial exception to patentability and not drawn directly to a product of nature. And so method of use claims generally get a quick out in terms of the 101 analysis, except in certain limited situations. And so the second italicized claim, a method of providing an apple. Here you have a claim, you have a simple step of providing an apple. You're doing nothing more than making available something that is already found in nature. And so that kind of negligible or insufficient kind of process step is not going to convert kind of that natural product, the apple, into a patentable method claim. And so you don't kind of get the benefit of getting kicked out of the analysis quickly. And so process claims, you're basically kind of out of the analysis before you're ever in it. The second significant difference, and this is called a streamlined analysis by the PTO. And by streamlined analysis, the PTO says the examiner should take a look at the claim right from the beginning, and if it recites a nature-based product, but when viewed as a whole, clearly does not seek to tie up a product of nature such that others cannot practice it, it's deemed eligible without even doing the Step A or the Step B analysis. And so here you have a little bit denser claim. The claim is directed to a fountain-style firework, and it comprises a number of ingredients, a sparking composition. We've underlined a couple ingredients that, in terms of the examples, are considered products of nature. Calcium chloride, the mineral, salt is known to exist. Gunpowder, when you read the examples, is a mixture of three known natural substances, intimately admixed. But the claim includes other things, like the cardboard body with a first compartment that has the sparking composition, a second compartment with the gunpowder, a plastic igniter. And so this claim, on its face, has a number of different kind of structural elements that are interconnected in a way. It's clearly man-made. And again, the examiners are instructed to do a streamlined analysis and not even run this type of claim through the Step A and Step B analysis. And so this would not even be subject to markedly different characteristics analysis or substantially more analysis of Step B. So at this point, I'm going to hand it over to Miklos. He gets the heavy lifting here. We're going to go through what a markedly different characteristic is and how the Step A analysis works.
Thank you. The new guidance also changes how nature-based product claims are going to be examined for eligibility. The most significant change in this regard is that nature-based products will be examined in Step 1, in the first step, for whether they are markedly different from the naturally occurring counterpart. This is very important because a judicial exception of product of nature is differentiated from a patent-eligible nature-based product by the presence of a marked difference between the two. So by examining the claim products in Step 1 for the presence of this marked difference, the examiner can find the patent eligible in Step 1 without having to go into Step 2 analysis. Additionally, the office changed its policy on what type of differences it will accept as a marked difference between the claim nature-based product and a product of nature. Under the previous guidelines, the office heavily emphasized the requirement for a structural difference between the two. Under the new guidance, the office now will accept not only functional differences, but also differences, not only structural differences, but also differences in function and or other properties. Together with the new guidance, the office also issued a number of new examples to show how it will apply the examination process to nature-based product claims. These examples also replace the previously issued examples, just the same as the guidance replaced the earlier guidance. Each one of these examples handle a set of claims that are important to a particular industrial field, and each one of them is set up in a little three-part story process where it lays out a fact pattern, it provides a number of claims, and then provides the analysis for the claims under the new guidance. When you look at the examples, make sure that you analyze and treat the fact pattern very carefully, because the outcome of the examination process is very much dependent on the presence or absence of certain facts. So on this slide, we included the example, example number 1 from the examples, just to provide you a little description of how the examination will proceed. Here, the claim is directed to gunpowder comprising an intimate finely ground mixture of potassium nitrate, charcoal, and sulfur. So under the new guidance, the nature-based product that is going to be examined for the presence of marked differences is the gunpowder, not the potassium nitrate, charcoal, or sulfur, but the claim mixture of the three. Then the examiner will, once identify the nature-based product, the examiner will look for the closest corresponding natural product. Because the mixture does not exist in nature, Therefore, the claimed mixture will have to be compared to the naturally occurring components as they exist individually. So in the analysis provided in examples, it comes clearly through that the office will take the explosive nature of the gun product, which is not present in the naturally occurring components as they exist in nature, as a markedly different characteristics between the claimed composition and the individual elements that exist in nature, and will approve the claim as patent eligible. So we have assembled on the next slide a number of examples just to show what type of characteristics the office will accept as markedly different characteristics for the different nature-based products. As you can see, chemical structure differences between the claimed nature-based product and the natural counterpart is still sufficient to establish patent eligibility. But in addition to structural differences, the office will look at functional ones as well, in like explosive property, or the slower spoiling of fruit juice, or bioavailability, increased bioavailability of a drug, the same for the solubility change of a component, as well as differences in crystalline forms. And the next slide shows that for biological substances, the office will accept, again, structural differences like changing glycosylation patterns, as well as changing other properties like the immunogenicity of a composition or the in vivo half-life of the composition. So just to make sure that we all understand that the office hasn't opened the door completely open to all and any and all product claims, here are a few examples where market difference will not be recognized. So the first couple lines shows that the fact that a particular composition is a purified composition or an isolated composition is not sufficient to establish that it's patentable, patent eligible over the naturally occurring counterpart. The office will still look for structural or functional or other differences between the claimed nature-based product, which is purified, and the product that it exists in nature. And it's important to point out also that the examples show that man-made is not enough. The fact that something was produced by a human is not enough to establish patent eligibility. Again, a man-made product is going to be examined whether it is markedly different from the naturally occurring counterpart. So after this introduction, we would like to go through a couple of the examples that are relevant for the different industries. And we are starting here with a claim directed to a beverage composition comprising pomelo juice and an effective amount of an added preservative. This claim is important to the food industries, and similar claims using naturally occurring product would probably be important for the cosmetics industries as well. So here the fact pattern provided with this claim explains that pomelo tree is naturally occurring, and people have prepared juice from it that they consume for a long time. It also discloses that the naturally occurring juice spoils within a few days because it contains some bacteria in it. And it also says that preservatives are known, and they can be either naturally occurring preservatives or non-naturally occurring preservatives. So in this claim, the claim is directed again to a composition that comprises juice and an effective amount of preservative. So the nature-based product that will be examined for the presence of a marked difference is the juice together with the preservative, and it is going to be compared to the juice as it naturally occurs. And in this example, the office shows that the difference in the speed of spoiling is a type of difference that is going to be recognized as a market difference that confers patent eligibility on the claim. Here, our focus is on the fact that change in spoiling rate is enough to establish patentability. Not every industry likes to use a preservative to achieve that. For example, pasteurization is used for milk and juices to keep it on the shelf longer. Based on this example, it is our opinion that one may be able to show that a pasteurized product is also patent eligible if you can demonstrate that the pasteurization results in a slower spoilage rate over the naturally occurring counterpart. Moving on to the next slide, the office examined the patentability, patent eligibility of mixture of microbes. These are naturally occurring microbes, not recombinant microbes. Most of you can recall that the Fong brothers decision from the U.S. Supreme Court, where the U.S. Supreme Court held that a mixture of naturally occurring microbes are not patent eligible if the mixing together of microbes did not change their properties. So just to quickly go through the fact pattern here, the claim is directed to rhizobium bacteria, nitrogen-fixing bacteria that lives in the root systems of clover, alfalfa, etc. These bacteria is able to infect the particular species of plants, but only one of them. And it was also known that if you mix together two of the bacteria and try to infect their host organism, then the presence of a second bacteria will inhibit the first bacteria's ability to infect its host. So what the applicant was discovered is that by mixing together different types of rhizobiums, you could create a mixture that can be applied to a wide variety of plants because they do not inhibit each other's ability to target their own host. And the claim was to an inoculant for leguminous plants comprising a plurality of selective mutually non-inhibitive strains and some other claim limitations. The U.S. Supreme Court found that this claim is not patent eligible because the non-inhibitive property of these bacteria was inherent to them, and there was nothing was changed on them. They are structurally and functionally identical to the naturally occurring products. Therefore, it is they are not patent eligible, and the office will still hold a claim to a mixture of bacteria patent ineligible unless the component bacteria changes in some terms of properties. And the next slide shows an example of the office's guidance for the types of claims that will be held eligible under the new guidance. Here, the claim is directed to an inoculant for plants that comprises a mixture of Rhizobium californiana and Rhizobium phaseoli. And the facts provided explain that R. californiana alone only affects lupine, but when it is mixed together with R. phaseoli, then the mixture of the two will infect not only lupine, but wild indigo. So here the presence of R. phaseoli changes the properties of R. californiana so that it can infect two different hosts instead of just one. And the office will view such a change in the pathogenicity of bacteria to make the composition, the claim composition of the two bacteria patent eligible. And I also want to note here that the examples expressly state that the possibility, the remote possibility that these two bacteria may be found somewhere in nature together is not enough to render the claim patent ineligible unless the examiner can provide an example where the two of them are found together. At this point, I hand back to John to discuss irrelated compounds.
All right. Give you a brain pause for 1 second. So I'm going to tackle example 3 in the guidelines. This is kind of a true natural product chemistry example. It reads like a law school exam, multi-paged, multi-question, multi-claims, but it really does illustrate of how the step 2A works for something where you're isolating some sort of compound from a plant or some other, an organism in nature. And so the fact pattern sets forth that the Amazonian cherry tree has a chemical useful for treating breast and colon cancers. And your inventor, the applicant, purified that chemical from the leaves and given it the name Amazonic acid. The purified form is structurally and functionally identical to the Amazonic acid in the leaves, so the impurities don't tend to change the properties. And so purifying it hasn't done anything new. Your applicant has created 2 new derivatives, 5-methyl Amazonic acid, a simple methyl ester, and then a deoxyamazonic acid, where the acid group has been reduced to an aldehyde. The 5-methyl ester is functionally different. It has a new property. It also stimulates the growth of hair in addition to treating cancer. The applicant has not identified any functional difference with the deoxy form of the acid compared to what was found in nature. And finally, this acid is very, very insoluble, and it's also absorbed through the lining of the stomach and rapidly metabolized by the body. And so the inventor has recognized that there are some problems in trying to formulate this as a drug, and has found some things and provides claims to this. So claim 1, purified amazonic acid. No market difference can be found in these facts, and so it's going to move through step A because it doesn't meet the market difference test, goes to step 2B, and ultimately it's going to be found when we look at step 2B to be ineligible, since there's nothing more other than what you find in nature but in a purified form. Claim 2, the methyl ester we were talking about. Here, simple methyl group replaces the hydrogen to make a methyl ester instead of the acid. This is going to be eligible. This is considered markedly different structure under the guidelines. It also has the additional property of related to hair growth, and so it has new properties. And so it meets the eligibility for 2 different reasons. Claim 3, the deoxy form, eligible. The deoxygenated form, where just the oxygen is removed, no acid, now the aldehyde, is considered a markedly different structure. And so, to the chemists that are listening, that comports with kind of our view of the world, that is a market difference. To the biologists, it may not seem like much of a change, and it doesn't line up perfectly with the gene-based examples where or the protein-based examples where bonds are broken and atoms are replaced, but that's not considered a markedly different structure. So next slide. So we've got here, what do we do with that compound? So the inventor's taken that compound, formulated it, and so claim 4, you have the acid, the naturally occurring acid, but it's surrounded by a layer of natural polymeric material, totally enveloping the core. And the analysis here is that you have a structural difference. The compound now is wrapped up in a natural polymeric core, and the facts are clearly state that you get different functional characteristics here. One, this polymer enables the acid to get through the stomach, reach the colon, where it breaks up and releases the compound and actually gives you a useful pharmaceutical product compared to the acid itself. It's a fairly straightforward call. That's eligible. Finally, last claim, the stable aqueous composition comprising the amazonic acid in combination with a solubilizing agent. The facts tell us that the amazonic acid is insoluble. The inventor was able to find a way to place it into an aqueous solution and keep it there by use of a solubilizing agent. Here, you've got a property of the amazonic acid that has been changed now, and so it's now stably dispersed or stably dissolved in an aqueous solution, and so that's markedly different from what's found in nature. So that's kind of the product of nature with respect to the compounds that you're going to find in a natural source. Genetically modified organisms. Here, the example, the facts relate to a naturally occurring Pseudomonas bacteria containing one stable energy-generating plasmid and capable of degrading a single type of hydrocarbon. That's known in the art. But there's no known Pseudomonas bacteria in nature that contain more than one stable energy-generating plasmid. These energy-generating plasmids take different hydrocarbons and chew them up. And so this is basically the Chakrabarty example. The claim indicates that the bacterium has to contain at least 2 stable energy-generating plasmids, each of those plasmids providing a separate hydrocarbon degradative pathway. Under Chakrabarty, we know you can patent these types of inventions. Under the guidelines, you can still patent those types of inventions. And the reason why is that you've got the second plasmid in there that has a difference in phenotype and genotype. It makes it different from what anybody knows to occur in naturally occurring bacteria, and so that's a marked difference. You're out step 2A, and you have patentable subject matter. Once again, the technology gets harder, and at this point, I'd like to turn it over to Miklos.
The examples also provide guidance for claims directed to polynucleotides and polypeptides. The examples for polynucleotides and polypeptides closely match each other, so we only included in the slides the examples for polynucleotides, but basically the lesson from here can be applied to polypeptide claims as well. So the first claim to examine here is directed to an isolated nucleic acid comprising sequence ID number 1. The fact pattern provides that seq ID number 1 is the sequence of gene W that includes protein W in the naturally occurring Virginia nightshade. We know from the Myriad decision from the Supreme Court that the claim to the isolated nucleic acid having the same sequence as a naturally occurring gene is not patent eligible because the isolated nucleic acid is not significantly different from the gene as it exists in the cell. The office's guidance to get around that obstacle and obtain a claim to something that encodes this naturally occurring protein is to patent the variant of the naturally occurring gene. So in claim 2 is directed to isolated nucleic acid comprising a sequence that has at least 90% sequence identity to seq ID number 1, and it contains at least one substitution relative to the native sequence. Now, the patent eligibility of this claim is dependent on the particular fact that no substitution modifications of gene W, the naturally occurring gene, are known to occur in nature. So keep in mind that while this claim might be patent eligible over the original sequence of gene W in the Virginia nightshade, it may not be patent eligible over the homologous gene that was cloned from a related species, for example, the West Virginia nightshade. So when you're trying to claim a genus of sequences by relying on variations in it, you have to keep in mind that even if you are eligible over all the currently known sequences, if a later isolated homologous gene falls within your genus, then the claim is ineligible. Nevertheless, the example sort of confirms the principle that variants of naturally occurring genes are patent eligible, and this is going to be important for the industrial application of variants of polypeptides, variants of enzymes that were developed for their superior properties. In case of these enzymes and nucleotides encoding those enzymes, we can rely not only on the structural difference between the naturally occurring gene and polypeptide and the improved version, but also on the fact that these improved enzymes will have functional differences compared to the naturally occurring enzymes. The next slide shows some more claims directed to polynucleotides and then by extension to polypeptides. The first one is directed to an isolated nucleic acid that comprises the native sequence of Virginia nightshade, and further comprises a fluorescent label attached to it. The office compares the claim composition, which is nucleotide sequence together, polynucleotide with a fluorescent label, to the native gene, and finds that they are structurally different from each other because the claim composition has this label, as well as that they are different in properties. Only the claimed nature-based composition has the property of fluorescing. And these two differences render the claimed nature-based composition markedly different from the naturally occurring counterpart. So this claim is a promising sign for diagnostic companies that developed various labeled nucleotide products for diagnosing diseases, well as a boon for the recently emerging therapeutic applications of using RNA-based products where the native nucleosides were replaced by artificial nucleosides to improve the half-life of the RNA molecules once injected into a human patient. The next claim is to a vector comprising the native nucleic acid and the heterologous nucleic acid sequence, i.e. A vector with an insert. And in this case, the combination of the two is compared to the native sequences. The fact pattern makes clear that the vector and the insert come from different organisms, meaning that a particular combination of sequences that are present in the nature-based composition cannot be found in nature, and based on that structural difference between the claim composition and the natural counterpart, the claim is deemed eligible. So the type of claim to a vector with an insert is something that would cover a product using gene therapy applications.
Miklos, would these claims have been treated differently under the old guidance, the spring guidance?
I believe that they would have been treated the same way because here we have structural differences between the claim nature-based products as well as and the naturally occurring composition. In the first claim, claim 3, to a nucleic acid with a fluorescent label, the naturally occurring nucleic acid does not have a fluorescent label on it, and so the addition of that label would have rendered the claim patent eligible even under the old guidelines. The real difference here is that under the old guidelines, the claim would have been examined under both steps, step 1 and step 2, and the markedly different characteristics between the naturally occurring composition and the claim composition would have only been used in step 2 to find it patent eligible. So under the new guidelines, the examination process is streamlined and you get eligibility faster. So moving on to antibodies, the examples have a number of claims directed to antibodies and then guidance on the eligibility of these claims. The first slide shows 2 claims, both of which are directed to a genus of antibodies. Claim 1 here is an antibody to protein S. The fact pattern provided for is that protein S is an antigen on a Staphylococcus bacteria that can infect mice, and because of these infections, the wild mice as well as wild coyote has antibodies. So in this case, the nature-based composition is the antibody, which is compared to the naturally occurring substance, which is antibody from a wild mouse. And given that there are no functional, structural, or otherwise differences between the two, claim 1 would be found ineligible. Claim 2 is directed to an antibody to protein S, wherein the antibody is a human antibody. We learn from the fact pattern that humans, the antibody against protein S is not known to occur in humans. So here the comparison would be between the claimed human antibody, which is the claimed nature-based product, and the naturally occurring antibody, which in case would be the antibody from either mouse or coyotes. And given that human antibodies, the sequence of human antibodies differs from the sequence of mouse antibodies, of coyote antibodies, there is a structural difference between the claimed product and the naturally occurring counterpart. And the fact patterns also disclose that, as we know, the injection of mouse antibody or coyote antibody into a human would create some problems with immunogenicity and immune reactions against the antibody. This is something that would not be a problem for a human antibody. And in the guidance, the office recognizes that the difference in immunogenicity between the claimed human antibody and the naturally occurring mouse antibody is also a difference that comes into play when they are looking for markedly different characteristics between the claimed product and the naturally occurring counterpart. So under this fact pattern, where no human antibodies to protein S are naturally occurring, claim 2 to a human antibody to protein S would be patent eligible. So I would like to point out that this example is particularly important for claiming antibodies against human proteins that are not known to be bound by any of the known human antibodies. So most of the therapeutically important targets for human antibodies exist in humans. Therefore, you wouldn't expect to find antibody against this because these are self-proteins. So under the guidelines, we would expect that claims, genus claims directed to, for example, cancer antigens would be found eligible. So I would like to also discuss here that even if an antibody to a particular target protein may be known to exist in a human, there are ways to limit the claims to avoid that naturally occurring antibody. For example, here we only discuss claims directed to protein S, which is a large protein with multiple antigens on it. So one could narrow the claim and still get meaningful coverage if we define the particular epitope within the protein, for example, amino acid residues 5 to 15. So even if generally known that there are antibodies against the particular protein in a human, for example, in autoimmune patients, the examiner would have to show that those autoimmune patients have an antibody against the particular epitope that is in the claim. So again, the office is kind of helpful, providing us guidance on how we can secure commercially relevant genus claims against antibodies. So the next slide shows the example in which the antibody is, the claimed antibody is defined based on the complementary determining region sequences, the CDR sequences. So this claim type is widely used to cover the particular therapeutic antibody that is being used. The CDR sequences are the portion of the antibody which determine the specificity of the antibody, and these claims are used very widely, and they are very important to us. So here the fact pattern discusses that while murine antibodies to protein S were known, none of those antibodies that are known to exist in nature have the particular combination of CDR sequences that are listed in the claim. So based on then the office compares the claim nature-based product, which is the antibody with the particular CDR sequences, and to the naturally occurring product, which is generally antibodies against against protein S, and the discussion focuses on the fact that there is a difference between the sequence of the naturally occurring antibodies and the sequence of the claimed antibody, and this structural difference is a marked difference between the two. Therefore, claim 3 on this slide would be eligible. And again, the example notes that the fact that this combination of CDRs may occur somewhere in the nature by chance is not enough to find the claim ineligible. Now, I would like to point out that while the guidance here is that claims to antibodies defined by CDR are generally patent eligible, there may be some exceptions where the particular antibody is derived, for example, from a human patient. So we have handled patent applications in which the claims were directed to an antibody that was isolated from a particular patient, and in those instances we actually received rejection for lack of patent eligibility for the examiner using our own specification and arguing that our own specification showed that the particular combination of CDRs do exist in nature. Nevertheless, this guidance is important to show that unique CDRs are patent eligible. So even if something is derived from an existing organism, from a human patient, if the antibody is modified, the CDR sequences are modified, for example, through in vitro affinity maturation, which is a process that is widely used to develop commercially relevant or pharmaceutically relevant antibodies, that will render the patent eligible. So the last slide on antibodies addresses the question whether modified antibodies are not. Here, the first claim is directed to an antibody to protein S, wherein the antibody is a chimeric or humanized antibody. So the fact pattern discusses that both chimeric antibodies and humanized antibodies include sequences from two different sources, from a human antibody as well as from a mouse antibody. And the office explains that given that these sequences come from two places, the claimed nature-based product will have a different sequence that is a different structure than either one of those sources, and this difference in sequences is sufficient to render the claim patent eligible. The last antibody claim that we are discussing here is directed to an antibody to protein S, wherein the antibody comprises a variant Fc region. So here the office discusses that changes in the Fc domain of an antibody changes its cytotoxicity and maybe changes its half-life. And these kind of changes in the property of the antibody are taken into account when the market difference analysis is performed for the antibody over a naturally occurring counterpart. And the office's guidance is that an antibody comprising a variant Fc domain is patent eligible over the naturally occurring antibody sequences. So next, I would like to turn to a particular type of claims, the product by process claims. So product by process claims are examined based on the product itself. This is true for the patentability of these claims, and the office will apply the same principle to patent eligibility. So a claim, product by process claim is only eligible if the product produced is eligible. For the sake of time, I'm not going to discuss the actual example given by the office. I just want to point out that we have seen product by process analysis by the office not only for true product by process claims, but also for claims directed to a recombinant antibody and the monoclonal antibody, where the office says that the fact that they are recombinant or used or produced by the monoclonal process is a product by process limit, a process limitation, and eligibility has to be established for the antibody based on differences between the claimed nature-based antibody product and the naturally occurring counterparts.
I guess the big point there, Miklos, is that the patent office is looking under that to see if the way of production results in any type of structural differences.
Yes. So the mere fact that an antibody is produced through a monoclonal process or a recombinant process is not enough to show eligibility. However, if that process confers to the antibody a markedly different characteristics compared to the naturally occurring counterpart, then the monoclonal antibody or recombinant antibody will be eligible. The next slide, we included the next slide just as a warning that claims need to be crafted very carefully to ensure that that it does not cover patent ineligible subject matter at all. So here the example comes from in vitro produced cells, which is relevant for the now developing tissue engineering products as well as for cell-based therapies. The fact pattern here discusses that human stem cells were isolated and cultured in vitro and differentiated into pacemaker cells. We also learned that the in vitro produced pacemaker cells, some of them at least, express on their cell surface a new marker, marker Z, which exists in the pacemaker cells, the natural pacemaker cells. The gene exists in the natural pacemaker cells, but that marker is never expressed on the surface. Therefore, some of the in vitro produced pacemaker cells express a cell surface antigen that is different from the naturally occurring cells. The FAT pattern also tells that this marker is not expressed on all of the in vitro produced pacemaker cells. So then let's turn to the claim. Claim is to an isolated man-made human pacemaker cell. As I already mentioned, the fact that the cell was isolated or that it was man-made is not enough to render it eligible. The office looks at the actual claim composition and determines whether the composition itself is different from the natural counterpart. Here, the comparison is between the pacemaker cells that were in vitro produced and the naturally occurring cells. And the fact pattern already discussed that the in vitro cells and the naturally occurring cells have the same genotype. They come from humans, and some of the in vitro cells are also phenotypically identical to the in vitro cells, in vitro produced cells. Therefore, the claim encompasses both patent eligible and patent ineligible subject matter, and as such a claim is patent ineligible under the recent Roslin decision. In Roslin, the claims were crafted to capture only the sheep that was cloned, and however, the claim was drafted in a way that covered not only a sheep produced through the cloning process, but also identical twins. And because that claim covered both the patent eligible sheep produced by cloning as well as identical twins that happen in nature, the claim was found ineligible. And sort of along the lines with the Roslin decision, the office provides that a claim directed to an isolated man-made human pacemaker cell expressing marker Z is patent eligible because in this case, the scope of the claim was limited to only cover those in vitro produced pacemaker cells that have a marker difference compared to the naturally occurring counterpart. In this case, the marker difference is structural, the expression of marker Z. So with that, I will turn it back to John.
All right, thank you, Miklos. Miklos has really walked us through applying Step A to a number of very relevant biotechnology claim types. We now kind of drop down into Step 2B. Now, Step 2B, kind of in these revised guidelines, hopefully with respect to products of nature and nature-based products, not a whole lot goes into this bucket, we're hoping. There's the streamlined analysis that goes before we even get into Step 2A, which if there's a lot of claim limitations that really kind of add to the nature-based element in such a way that you're claiming something that's not kind of taking something out of public domain as this nature-based product, you're not even in the analysis. The Step 2A analysis also, because of the markedly different properties, structural or function, should kind of get a number of inventions kind of out of this test. But you know, we've seen things like the isolated sequences, the isolated proteins, isolated cells, where you can get down and you drop down into Step 2B. Step 2B now it's trying to determine, you know, what more has to be in the claim as a whole to make this directed to something other than a natural phenomenon. And Step 2B, you consider, you know, the claim as a whole, is there any element or combination of elements that's sufficient to ensure that the claim amounts to significantly more than the judicial exception? I think what you'll see in the later webinars is you'll be spending a lot of time in this section with the nature-based products. Hopefully there's not a lot of time spent. We basically have one example to take a quick look at. Probably if you could skip 2 slides. So here the facts are, again, we're looking at the same isolated pacemaker cells. And we have 2 claims. This first claim on this slide is just the population of these cells in a container. And the cells, you know, are a product of nature. And the man-made limitation doesn't make them any different from the naturally occurring in terms of structure or function. And they're sitting in a container. The container is really adding nothing more to the cells themselves. It's required for growing and using the cells. They recited a very high level of generality. The Patent Office is going to take a look at a claim type that looks like this and find that it doesn't meet Step 2B. And it's going to drop you out, and you will be ultimately found ineligible under 101. Contrast that with this next slide. Here the claim is a population of the same man-made human pacemaker cells, but now they're in association with a biocompatible 3-dimensional scaffold. This biocompatible scaffold is not required for growing the cells. It's recited at a little bit higher level of generality. It's still not a lot, but at least it's more than a container. And here, particularly important, is it's directed to a particularly useful application of the population of cells. The cells can be placed into this scaffold, and you can repair cardiac tissue. Without that scaffold, you're not going to be able to do that. And this, impacts directly the technology of regenerative medicine. Here, PTO looks at this and says, this is something that needs a significantly more test, and that's going to pass through step 2B and be eligible. And so it's a subtle difference from some of the things we looked at in step 2A with markedly different, but there it is. And I think there'll be a lot of examples that people think of and that actually happen in practice that will kind of put these guidelines to the test looking forward in the future. They seem to work well kind of looking back in the past, but it'll be up to us to use these. And I think that's our last slide coming up is practice tips. I think the guidance and the examples are here. They're useful, very useful, I think, for crafting strategy for establishing eligibility. And the strategy comes into play in what you're claiming and what you're putting into your specification. For new applications, make sure you're describing properties and including data that will demonstrate markedly different characteristics. For existing applications, think about having at least fallback claims where your compositions can be shown to be markedly different from naturally occurring products, either in structure or a physical property or a biological property. We don't think it's a winning move to have to rely on the significantly more prong by not having markedly different characteristics. There is going to be adding a number of limitations into the claim, and the more limitations you add, of course, the less infringers you can ensnare. Establish multiple markedly different characteristics to support eligibility to ward against the later discovered naturally existing composition, rendering the claim ineligible. This goes to Miklos's point that sometimes those naturally occurring things are out there, but you don't know about it, the examiner doesn't know about it, but an infringer is going to find them later on when you really need the patent claim. Draft claims. This is hard. You want to generically cover as much as you can, but in doing so, sometimes you happen to ensnare the natural product. And so, think about how you can have fallback claims that make sure that you eliminate, by using positive or negative claim limitations, what the naturally occurring product is. Method of use claims. It's an easy out of this analysis. Most method of use claims for compositions encompassing a naturally occurring product are going to be patent eligible. And again, be prepared for surprises. Take the time to put fallback positions into your applications as these kind of guidelines are developed and the cases come down interpreting the Supreme Court case law, and the Patent Office kind of tees up some of these issues while we're going through prosecution. So hopefully it's been help to you, and looking at the guidelines, we encourage you to go to the Patent Office website, look at the guidelines, look at the examples. They will raise a number of questions in your mind as you try to put them into play in your daily practice. And we'd like to thank you, and have a great day.
Thanks so much for participating in today's presentation. We will have both PDFs of the PowerPoint slides as well as a recording of today's presentation made available. So if you're interested, again, please send an email to myself, Erin West, at ewest@skgf.com. And thank you again. You're welcome to disconnect your line now.